I'm glad to introduce you to my first conference presentation. It's called Does the Robot Get the Credit? And yeah, the next 15 minutes I will explain to you how we explored the mechanisms of expectancy violations during human-robot interactions. But first of all, I want to introduce ourselves, and yeah, me presenting today, that's Marcel, and I'm presenting this collaborative work between Dr. Szczuka, Dr. Krämer, and me. Now let's dive into the topic and explaining the basic theoretical background of our investigation, negative expectancy violations. First, imagine that you're moving to a new apartment and don't know how to carry all your stuff. You might ask your friends to help you carrying, because they're your friends and you expect them to help you. Unfortunately, it happens that not all of your friends have time when you need them. In this scenario, friend B rejects to help you because he had a busy and exhausting week. Because this rejection to help is an outcome which is worse than your expectancies, we call it a negative expectancy violation. The same thing applies to non-living objects as well. If our expectancies are met because, for example, your vacuum cleaning robot has cleaned your flat properly, everything's fine. If your expectancies are violated in a bad way, a negative expectancy violation, NEV, occurs, which might have serious consequences for future interactions. Examples for these bad consequences which were found with regard to robots are decreasing ratings of trustworthiness, reliability, task attraction, and many more. Obviously, these adverse effects can negatively influence future interactions with robots and should therefore be avoided if possible. Although single studies also describe neutral or even positive outcomes of failures made by robots, the majority of research lends evidence for an adverse effect. However, most of these studies focus on single-time interactions only and do not make medium or long-term interaction, don't take them into consideration, because most of human-robot interactions are supposed to be longer-term interactions. But would you always be mad to a friend for rejecting helping you? Possibly not always. Here, the concept of idiosyncrasy credit offers explanation how the bad effects of negative expectancy violations can be avoided. How does this work? Going back to our example of the help request for carrying bags and boxes, you might remember that your friend B, who does not have time to help you now, has gladly helped you in the past with other removals. You agree that he has helped you so much in the past that it is totally fine for you that he doesn't help you today. This tolerance against an individual's deviation from the norm is called idiosyncrasy credit. More scientifically spoken, in words of Hollander, idiosyncrasy credit describes the degree to which an individual may deviate from the common expectancies of the group. In other words, it's a social resource which will be used and reduced instead of negative social consequences based on deviations from any existing norm. This credit can be accumulated by three factors, which Hollander and other researchers like Ridgway describe. The first one is an individual's task competence. So if one has a high task competence for a task that one's group is faced with, then yeah, you can gain credit through solving this task for your group. Secondly, personal characteristics like your willingness to contribute to the group is important as well. The third a thing that contributes to your idiosyncrasy credit is your past behavior. So if there are any situations in the past in which you acted against the group's interests, then yeah, this will probably lower your idiosyncrasy credit. Now, the questions that arise from all this theoretical background is, with regard to human-robot interactions, how does a negative expectancy violation affect people in medium-term interactions with a social humanoid robot? And moreover, how does the concept of idiosyncrasy credit might be able to counter this process? Now, in order to answer these questions, I will start to describe the study we conducted for this purpose. Our study made use of a 2 versus 2 between subjects design. The first independent variable that we manipulated was the robot's group supporting behavior. According to the works of Holland and Ridgway, the robot behaved group-oriented and task-competent in half of the conditions in order to allow the acquisition of idiosyncrasy credit, or he acted selfish and task-incompetent in the other half of the conditions. The second independent variable was the negative expectancy violation, which took place or took not place for half of the participants each. Details on how this design was realized will be following soon. So, for example, one participant might have been in a group where the robot acted group-oriented and task-competent, and in which the robot committed a negative expectancy violation. That would have been one condition, for example. All in all, we were able to recruit 80 participants for our study. In most parts, they were students. The special feature of our study was the fact that, in contrast to many previous studies, we used a 3 sessions design. So participants had to come to our laboratory at 3 different dates to make sure it's not a one or single time interaction with the robot. The robot we used in the study was the humanoid robot now, which you can see here on the slide. And yeah, he asked me to introduce himself to you. So yeah, just go now.
I did not listen to you, but your answer does not seem interesting to me anyway. I just go on with the next question.
So this was an example of a negative expectancy violation. The robot wasn't really insulting a person, but he acted rude and impolite to the participants' answers. So thank you very much now. In order to give you an overview of how the sessions procedures looked like, here you can see a short overview of our study schedule. The first of the 3 sessions was the longest and was used to create similar expectancies towards the robot now during 4 different interaction tasks, which you can see at point G12. These games were used also to manipulate our independent variables over the whole course of the study. During an adapted version of the desert survival game and the prisoner's dilemma, the robot's group support was manipulated. So he acted either task competent and group oriented or task incompetent and not group oriented. In addition to that, the word sequence game was used to manipulate the robot's task competence by letting him giving correct or false answers to given questions. The basic procedure remained similar during the following session 2, except for the fact that during the second Q&A game, the negative expectancy violation took place. We already saw what the robot's answers to the participants' answers were, so we reacted rather rude and impolite to their answers. What were these questions? Yeah, the robot just asked them questions about their everyday life, and yeah, the robot just simply ignored these answers or yeah, commented in a bad way. During the last of the 3 sessions, however, no expectancy violation took place anymore, and it was a session very comparable to session 1. As you can see, we had multiple spots where we assessed variables during our questionnaire spots. And now I want to tell you which dependent measures we assessed during the study. This was basically the trustworthiness, likability, social and task attraction, as well as the height of idiosyncrasy credit based on a scale offered by Estrada and colleagues. Yeah. Now, when we come to the results, I just want to present you our hypothesis and then show you the results we analyzed for them. I won't show all our hypotheses here because it would take too much time, but all the others you can read up in the paper. Our first and very important hypothesis was that, referring to previous authors' insight, that negative expectancy violations can cause a worse rating of a humanoid social robots in terms of likability, trustworthiness, compared to a robot with expectancy consistent behavior. Therefore, we calculated repeated measures ANOVAs with contrasts with the negative expectancy violation as an intersubject factor. Analysis revealed significant differences between conditions without expectancy violation, here marked in darker colors, and with expectancy violations, here marked in lighter colors, which is shown here exemplary for the construct likability. Thus, people's likability rating was significantly higher in conditions where no expectancy violation took place. Based on the diagram, you can descriptively see that the worst decrease was after the negative expectancy violation took place, and also that the ratings equalized themselves over the whole course of the study. The same significance was obtained for trustworthiness as well. So also trustworthiness was affected by the negative expectancy violation. Although the means for social and task attraction show a similar decrease, they didn't become significant during our analysis. The second very important hypothesis of ours was that a robot with group-oriented and task-competent behavior will acquire more idiosyncrasy credit than a robot that acts self-oriented and not task-competent. So basically all the assumptions that Hollander and colleagues like Ridgway already expressed. Therefore, both conditions with negative expectancy violations were analyzed over time. However, no significant differences in the height of ascribed idiosyncrasy credit could be measured, no matter if the robot was group supportive or not. So we had to reject our second hypothesis. Our fourth hypothesis was, I skipped the third one, you're all right, but our fourth hypothesis was that we were interested in the differences which would occur between a robot that in both cases violated people's expectancies, but in one case was group-oriented and task-competent, and in the other acted selfish and not task-competent. And we would suggest that the robot which acted group-oriented and task-competent would receive higher ratings of likability, trustworthiness, etc. This was only true in parts because the robot only received higher likability and task attraction ratings. So this hypothesis was not could not be rejected, but it was only true in parts, or we received only evidence for some aspects of this hypothesis. Because this was a massive amount of information, I want to sum up all the major results of our study now for you. And the most important thing, I guess, is that the negative expectancy violation was able to reduce people's likability and trustworthiness ratings related to the robots significantly. This is in line with research on single-time interactions from other authors who discovered these effects as well. Our negative expectancy violation did produce differences immediately, although not all dependent variables were affected equally. However, this devaluation of the robot proved to be rather temporal and not time persistent. During the third of 3 sessions, the ratings were not different anymore between conditions, indicating that long-term effects were not measurable, but only short-term effects. Next to these findings, it is important to state that the concept of idiosyncrasy credit proved to be not applicable to human-robot interactions, during our experiment at least. However, people's evaluations recovered quickly and were in parts better in conditions with a group-supporting robot. One might argue that our conception of a robot's deviation tolerance was not sufficient enough, and that other factors such as time or people's high overall ratings at the beginning of the study needed to be focused more on. But in addition to our findings, we want to name some limitations that need to be recognized to interpret our study. We had technical errors during the conduction of the study, so the robot and all the other technical equipment had problems, so we had to cancel and repeat single sessions. And yeah, furthermore, we only used one type of robot with only one type of expectancy violation in only one type of interaction scenario. So there's a lot of room for further research on this topic. Furthermore, we had many people who previously interacted with the robot now, which was critical. And also the scale for measuring the height of idiosyncrasy grid could have been a bit better because differences were not always measured that were actually there. So yeah, it was very fast, but I hope to have given you a good overview of our study. And now I want to say thank you for listening, and I'm happy hearing questions from you.